You've been working on solving equations with variables on both sides, and up until now you've always only got one solution for your equation. But now we're going to take a look at situations where it could be infinitely many solutions. In fact, we say it's all real numbers. Any number would work. Or no solution at all. It's an equation that is unsolvable. No number at all would work in there. So what does one solution look like? Well, typically we use x, but you've seen that we've had many other variables out there, but it would be the variable, say x, equals a number. Just, that means any number. And that's kind of typical when we get that. That seems pretty usual for most of the equations that we've solved. But the other two interesting situations that happen are, well, what if you get a number equals itself? So a number equals itself. For example, maybe I get 3 equals 3. Well, because this is a situation that is always true, our answer would be all real numbers. It's always true, so anything works. Another situation that you can get is a number equals a different number. Something that is never true. So, for example, maybe I'd get 4 equals 7. This is a never true situation, and therefore we have no solutions. Where the one prior to that, the all real numbers, this is always true. When does 3 equal 3? Always. When does 0 equal 0? Always. But when does 4 equal 7? Never. That's never going to happen. So let's go through and refresh, solving the multi-step equations. It can have variables on both sides to get these three situations, or it can have variables only on one side to get these situations. And we'll look at both scenarios. So your first move is to make sure that you simplify each side of the equation before you start to solve. So I want to get it down to a situation where I have a number and a variable equals a number and a variable. And so I have 21 minus 5n on the left-hand side. That one's in pretty good shape. I have a number and a variable term. And now I'm going to simplify the other side. So negative 8n, distribute minus 2n plus 16. Well, I can still combine like terms. So 21n minus 5n still hasn't changed. I do the other side, negative 8n minus 2n, meaning I clean up the other side. Negative 10n plus 16. Now I'm in a situation where I have variables and numbers on each side, a number and a variable term and a number on each side. And so now I need to remove one of the variable terms from one side. And one recommendation is you take the smaller term. And a lot of time that works. So the smaller of my two variable terms would be negative 10n, so I'm going to add 10n to get rid of it. And I'll have 21 plus 5n equals 16. Well, now I want to get the variable by itself, so I can remove the 21 on both sides. I'm running out of room, so I'm going to move that up and over here. I'm down to the point where I have 5n equals negative 5. Divide by 5, divide by 5, and n equals negative 1. This is a one solution situation. I have a variable equals a number. Let's take a look at the other two types of scenarios that we can get. So when I work through this next problem, I'm going to start the same way. I want to clean up each side. I'm going to distribute and combine like terms on the right. So negative 6 minus 7m plus 7. Remember, that's a minus and a minus make a plus. I can combine the negative 6 plus 7, so I have 5 minus 7m equals 1 minus 7m. And now I have to pick the smaller variable part. Again, that's a technique that works a lot of times, unless I have a side that maybe only has one variable, and then the other side has a variable and a number, and then I might have to do a different technique. And we'll see that in action as well. But right here, they're both the same. So I can choose any one to get rid of. And what happens is it ends up both sides are gone. Well, this is that scenario where I've got a number equaling a totally different number. When does 5 equal 1? This is a never true situation, and therefore we have no solution. And so we write no solution for that one. For problem number 3, we're going to continue in the same fashion. I'm going to be cleaning up, but if you notice, I only have variables on one side of this equation. So on the left-hand side, the negative 8 is all by itself. On the right-hand side, I'll combine like terms. 7k minus 3k minus 4k, well, that's 0k. And then negative 2 minus 6 is minus 8. Well, 0k is like 0, so I have negative 8 equals 0 minus 8, or negative 8. Negative 8 equals negative 8. That's always true. So we call this all real numbers. We have an abbreviation for that because in math they do. You don't write out plus, P-L-U-S, every time you want to add two things together. You don't write out minus. You don't write out E-Q-U-A-L for an equal sign. And we don't have to write out all real numbers. We do this fancy kind of R. It's a double thick straight line R, or I've also seen it written where they just do a little curly QR. But that just means all reals. And so you could write all real numbers, or you could do the fancy solid R or the fancy curvy R. All real numbers, that represents. And so that happens again when you get two numbers that are the same on each side of the equal sign. My next one is a pretty quick one. I have 4p minus 4p, 0 equals negative 3. Right away I found out, when does 0 equal negative 3? That's a never true situation. We call this, again, no solution. I should go back to that no solution. I've also seen people write that like that, where they write it as a null set. There's no solution set for this one. And so that's, like in the last one, we could abbreviate with that fancy R. We can abbreviate a no solution with that null set or empty set. All right, there's one last thing that I want to point out before we call it a day. And so I'm going to work through this problem here, number 5. Actually, I'm going to skip. I'm going to move to number 6. I should have done number 6 first, actually, because I want to point out something. So a lot of times when we're solving, we might end up with a situation. I distribute the 3 here. I get 3p plus 12 equals, I'll distribute the 4. I'll get 24p plus 12, and I'll subtract this 3p here, minus 3p. I chose the smaller one, so I have positives. I get 12 equals 21p plus 12. Then I'm going to remove the 12 on the right-hand side, and I end up with 0. And a lot of people see this and they go 21p. Okay, 0 equals 21p. And they feel like, oh, that must be a no solution, because how can 0 equal 21p? How can 0 equal negative 3? Well, there's a variable in this, and I can actually get a solution. When is 21 times p going to equal 0? Well, if I divide out the 21, that's when p itself equals 0. So be aware of that. When you have 0 equaling something with a variable in it, I can still solve it. Don't jump the gun and say, oh, that must be a no solution. Because I have the variable in it when I divide the 21 out, I can get a solution for that. So that one actually is a one solution situation, and my solution is that p is 0. Why don't you try this last one? You can pause the video and try it, and then come back and see how you do. I will pause it myself, and then you can take a look at the solution. So I distributed and then ended up combining the like terms on the right. I got it down to 5x plus 5 equals 5x plus 5. Removed the one variable. part, or a variable part from one of the sides, left me with 5 equals 5. So my solution is all real numbers, and I choose to do the curved fancy R. But remember, that means all real numbers. All right, so give the problems below a try. And as always, if you have questions, send me an email. Good luck, and I will talk to you soon.